Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize patterns in the graphs of quadratic equations, how to determine the vertex of a quadratic equation, how to recognize the line of symmetry of a quadratic equation, and how to graph quadratic equations on the coordinate plane. How are we learning it? Through the Graphing Quadratics Part 2 notes and the Graphing Quadratics Part 2 assignment. When can we use this information? To determine the distance of a home run in the Major League Baseball Home Run Derby. How do you know you learned it? By getting a score of 4 on the Graphing Quadratics Part 2 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Graphing Quadratics Part 2 notes, and then I'll give you time to complete the Graphing Quadratics Part 2 assignment on IXL. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Quadratics study guide and any incomplete assignments that you may have. Let's take a look now at the Graphing Quadratics Part 2 notes. The notes begin with the learning goals and success criteria. Now, what does the graph of a quadratic look like? The graphs of quadratics are parabolas or U-shaped curves. They look like this. So it forms this perfect U-shape and goes down and then comes back up. And it could also go the other direction. It could start by going up and then return down. So these are quadratics. So how do we graph quadratics? Well, we need certain key pieces of information. The first one is, what direction does it open? So is it starting by going down and then coming back up, or is it starting by going up and then coming back down? So we need to know which direction it opens. We need to know the roots. So where does it cross the x-axis? We need to know the vertex. We need to know the line of symmetry. So line of symmetry, it's going to form a perfect U shape, so it's going to be the same distance from that line of symmetry on each side. So it should look like a perfect reflection. We need to know the maximum and minimum. We need to know the domain and range. So let's look at each of these components. First of all, the direction it opens. So the first one is opens up. Notice, as we go up, it gets wider and wider. That's opening up. Now opening down would be the opposite. So here, it's getting wider and wider as we go down. So that's opening down. So opens up, opens down. Now the graph opens up if the lead coefficient, so the number in front of the x squared term, is positive. So as long as the number in front of the x squared term is positive, it opens up. For instance, 3x squared minus 4x plus 3. The 3 is positive, opens up. Now, it's going to open down if the lead coefficient is negative. For instance, negative 3x squared plus 4x plus 3. So it doesn't matter that all these terms are positive. If this term here is negative, the entire thing is going to flip and open down. Now, the line of symmetry. So if we draw a vertical line right through the vertex, right through here, we should be able to see a mirrored image. So if we look here, here's my vertical line right through the vertex, and notice this point here and this point here should be exactly the same distance from this line. If I pick any other point, this one and this one, they should be exactly the same distance from the line of symmetry. So it's reflected. If I were to take this and flip it over, it should land directly on this one. So this is our line of symmetry. And the line of symmetry always is the x value of the vertex. So my h here, that would be my exact line of symmetry. So in this case, let's say that our vertex is at 2, negative 3. So our line of symmetry would be at x equals 2. Okay, what are roots? Roots of functions are the points on the graph of a function where the y values are 0. Another way to think of this is where the graph touches the x-axis. So we call these roots, we also call them sometimes roots, zeros, solutions, and x-intercepts. So all of those are different things that roots can be called in different ways. So what does a root look like? It's an x-intercept, or where the line crosses the x-axis. So it crosses here, and then it comes back down and crosses here. We call those the roots. So how do we find the roots of a quadratic? Well, the first step is factor the quadratic. So factor it any way you can, and then solve for the roots. So when we get here, we have x squared minus 5x plus 4. We would use our magic x, and once we do that, we should see that x minus 4 times x minus 1 is equal to 0. So we factor this out. Now we take each of those parts and set them equal to 0. So x minus 4 is equal to 0, and x minus 1 is equal to 0. Now we just solve for x. So we add 4 to both sides, and we get x equals 4. We add 1 to both sides, and we get x equals 1. So the zeros, or the roots, or the x-intercepts, whatever you want to call them, those ones for this equation are x equals 4 and x equals 1. Let's look at another example. We have x squared minus 5x is equal to 0. So again, we factor this, and we can pull an x out of this. So we get x times x minus 5 is equal to 0. Now we set each of those parts equal to 0, and that includes the x. So x can equal 0, and x minus 5 can equal 0. Well, x minus 0 just stays as is. It's just x equals 0. So that's one of the roots. The second one now, we add 5 to both sides, and we get x is equal to 5. So x equals 0 and x equals 5 are the roots for this quadratic. Now what about quadratics that can't be factored? So not everything comes out evenly. So not all quadratics can be factored. For instance, this one, x squared minus 5x plus 3 equals 0. This is a non-factorable quadratic. So when we get these non-factorable quadratics, we have to use what's called the quadratic formula. So what is the quadratic formula? Quadratics will always appear as ax squared plus bx plus c equals 0. And from that, we can create the quadratic formula, which says this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's take a look at an example of how that works. First thing we need to know before we get started, though, is what is the discriminant? The discriminant is the part under the square root. If the value under the square root is positive, then we have two roots. And if the value under the square root symbol is negative, there are no roots. So that's why we call it the discriminant, because it discriminates here against negative roots. So if it ends up negative, then we know we don't have to do any other work. It's no solution. Okay, so let's take a look here. So we're given x squared minus 5x plus 3 is equal to 0. And we're asked to use the quadratic formula. So we're going to plug in. So negative b, so that becomes negative 5, which is positive 5. Plus or minus negative 5 squared minus 4 times a, which is 1, times c, which is 3, over 2 times a, which is 1. And we end up with this. So all I did was take and plug in to the formula. Now we can go ahead and start to work the problem. So negative 5 is just positive 5. Negative 5 squared is positive 25. And then negative 4 times 1 is negative 4 times 3 is negative 12. And then 2 times 1 is 2. So we end up with this. Now we just simplify under the radical. So 25 minus 12 is 13. So we get 5 plus or minus square root of 13 over 2. Now, notice there is no perfect square root of 13, so we just leave it as is. And we make this a plus, so this is 5 plus square root of 13 over 2. And then the minus part comes in, so this is 5 minus square root of 13 over 2. So anytime you see this plus or minus, that means we're going to do two things. We're going to add it and then subtract it. So we're going to do both to it. So here's our addition, here's our subtraction. These are our two roots. So look at another example. We have 2x squared minus 5x plus 3 is equal to 0. So we're going to plug it into the formula. So we plug negative 5 in for b. We plug, again, negative 5 in for b here. We plug 2 in for a, and we plug 3 in for c, and then we plug 2 in for a down at the bottom. We get this. We simplify. Negative 5 is just positive 5. Square root of 5 squared is 25. And then negative 4 times 2 is negative 8 times 3 is negative 24. And then 2 times 2 is 4. So we end up with 5 plus or minus 25 minus 24 over 4. Well, 25 minus 24 is 1. And then the square root of 1 is just 1. So now we end up with 5 plus or minus 1 over 4. So now we're going to go ahead and solve this. So this is 5 plus 1, which is 6, over 4. 6 over 4 is equal to 3 halves. And then we do it again. 5 minus 1 is 4 over 4, which is equal to 1. So our roots for this one would be 3 halves and 1. Let's look at one more example. We have 3x squared minus 5x plus 3 is equal to 0. So we plug everything in, and we end up with negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 over 2 times 3. And when we simplify that, negative 5 is positive 5. Negative 5 squared is just 25. And then negative 4 times 3 is negative 12. Times 3 is negative 36. And then 2 times 3 is 6. So we end up with 5 plus or minus 25 minus 36 over 6. Well, what we should notice is when we combine these, we end up with negative 11. Well, going back to our idea of a discriminant, we know that if there is a negative under the radical, there are no roots. So in this case, we would just say there are no roots, or we'd say no solutions. So how do we know that there are no roots? If we take this equation and put it into Desmos, it looks like this. Well, we can see that it still forms a parabola, just like all the others do, right? That U shape. But notice it's above the x-axis and it never comes down and touches. So there are no roots there. Okay, just a reminder, you need to simplify under the radical all the time. So let's say you end up with square root of 12 under the square root symbol. You always need to simplify it as much as possible. And the way you do that is you're going to try to find the greatest square factor. So for instance, what we think about the factors of 12, and we recognize that the factors are 1, 2, 3, 4, 6, and 12. And we want to pick out which ones are perfect squares. Well, we know that 1 and 4 are perfect squares, but we only want the biggest one, so 4 is the biggest perfect square. So that's really 4 times 3. So we could take the square root of 4. The square root of 4 is 2. So this becomes 2, and then we leave whatever's left under the square root, which is 3. So this becomes 2 square root of 3. Simplifying fractions, remember once you're done and you get your answer, make sure that you simplify the fractions as much as possible. So let's say I get 4 plus or minus 2 times the square root of 3 over 2. If this value in the denominator goes into both evenly, then you need to go ahead and divide it. If it only goes into one, then you leave it, because it has to go into both. So 4 divided by 2 is 2, and 2 square root of 3 divided by 2 is just square root of 3. So we end up with 2 plus or minus the square root of 3. There's a video here now that you can watch that shows you how to check your roots for quadratic equations using Desmos. So go ahead and watch that video. Let's talk now about how we can use Desmos to check the roots of a quadratic equation. So first of all, I'm going to go to desmos.com, and then I'm going to go to where it says Graphing Calculator. And if you notice, it should take you to a page that looks like this, where it'll have the graph on this side. We just need to enter the equation over here on the left. So let's go ahead and do that. So let's say it's y equals 2x squared plus 5x minus 2. Well, as we can see, we have our graph that pops up here. And there's two places where it crosses the x-axis. That represents the roots. So if I click on it, I'm going to find the x-coordinate, which is right here. And I can see that the root for this one on this side is negative 2.851. And if I go to the other side, the root on this side is 0.351. So no matter which equation I type in, so I can type in y equals x squared. There's my second one. I can find where it touches the x-axis right here. And if I click on it, it will give me the root, which is the x-coordinate of that point. So this is how you would use Desmos to check the roots for a given quadratic. Now, first of all, what is the vertex of a quadratic? The vertex of a quadratic is the point where the graph changes directions. So what that means is it might start by going up, but then it's going to change directions and start coming back down. So that is a change of direction. So example would be right here, we're going up until we reach this point right here. As soon as we reach this point, we start going back down. This point right here would be considered the vertex. Now, how do we find the vertex? The vertex of a parabola is found by using this formula. A times x minus h squared plus k. Now, this should look pretty familiar because this is basically the completing the square of a quadratic. So the h value is the x-coordinate. Now, what is a perfect square trinomial? A perfect square trinomial is a trinomial that looks like this. X squared plus 2bx plus b squared. So b is some value. It'll be actually a constant. And the number here should be exactly double it. So an example of this would be x squared plus 6x plus 9. So we know that 9 is 3 squared, and 3 times 2 is 6. So this is a perfect square trinomial. When we factor this, we recognize that this becomes x plus 3 times x plus 3, or x plus 3 squared. We'll look at another example. Now we have 2x squared minus 12x minus 4. So we're going to factor out the lead coefficient because we can't complete the square if there's a number in front. So we're going to divide everything by 2. So now we get 2 times x squared minus 6x minus 2. Now we go through our steps like we did before. So we take negative 6 and divide it in half. Well, negative 6 divided by 2 is negative 3. We square that and we get 9. So that's what we need it to be. But instead we have negative 2. So we need to rewrite this. How do we get from 9 to negative 2? Well, we subtract 11. So now we have 2 times x squared minus 6x plus 9 minus 11. Now we rewrite it as a perfect square trinomial. So we get x squared minus 6x plus 9, and that becomes x minus 3 squared. And then we take this part and we just need to distribute the 2 back to it. So 2 times negative 11 is negative 22. So we get 2x minus 3 squared minus 22. Now there's a video here that shows you how you can use Symbol Lab to help check your work when completing the square. So go ahead and watch that video now. Let's take a look now at how we can use Symbol Lab to check our work when working with completing the square. So we go to Symbol Lab and we go to the completing the square calculator. We're going to go here and type in our equation. So let's say it's x squared minus 4x plus 9. We're going to go ahead and click go. It shows us what it should be at the end, which is x minus 2 squared plus 5. And if we scroll down, it'll actually show us the steps of how to get there. So here's how we would do that. So this is one way that you can check your work when completing the square using Symbol Lab. Now, how do we find the vertex then? So once we've completed the square, now we just plug this in. So we recognize that this is the h value, and it's always supposed to be minus h. So my h value is just here, so this is going to be positive. So it's positive 3. And then my k value is supposed to be positive, so this one's negative, so it would be minus 22. So my vertex would then be 3, negative 22. So that's how I find the vertex once I've completed the square. Now there's a video here showing you how you can use Desmos to check your work when trying to find the vertex of a quadratic. So go ahead and watch that video now. Now let's take a look at how we can use Desmos to check our work when checking the location of the vertex of a quadratic. So we go to Desmos.com and we're going to click on Graphing Calculator. Now whether it's in standard form or vertex form, we can type it in either way to check our work. So we can type in y equals 2x squared minus 4x plus 3. And we can see the exact location of the vertex. And if we click on it, it'll tell us exactly where it is. So it's at x equals 1, y equals 1. We could also do it in vertex form. So y equals x minus 3 squared plus 5. And we can see here that our vertex, if we click on it, is at 3, 5. So this is how you can use Desmos to check your work when trying to find the location of the vertex of a quadratic. Now, how do we actually graph the quadratics? First step is plot the vertex. So we need to find the vertex and then plot that. Then we plot the roots or other points. So if there's no roots or if the roots aren't easy to find, that's okay. Use a table and find 2 other points. So plug in values for x, solve for y, and plug those points in. Notice that it should be reflected. So whatever point I have on one side, I can just copy it to the other side. I don't actually have to solve for it anymore. Then I just connect the dots and form my U shape. So for instance, I have y equals x squared. So I plot the vertex. I should notice that this is really x plus 0 squared. So my vertex should be here at 0, 0. Then I plot 2 other points. So when x is 1, 1 squared is 1. So when x is 1, y is 1. So I plot that. Now I should notice that it's going to be exactly the same distance over here. So I went to the right one, up 1. So I'm going to go the same thing the other way. So to the left 1 and up 1. And plot my point. Then I'm going to use another point. So now I plug in 2 for x. So when x is 2, y is 2 squared, which is 4. So when x is 2, y is 4. So I plot that point. Then I do the same thing. So I went to the left 2, up 4, right there. Plotted that one. Now I can just connect the dots, and there's my U shape. Now there's a video here that shows you how you can check the graphs of quadratics using Desmos. So go ahead and watch that video. Now let's take a look at how we can use Desmos to check our work when checking the location of the vertex of a quadratic. So we go to desmos.com, and we're going to click on Graphing Calculator. Now, whether it's in standard form or vertex form, we can type it in either way to check our work. So we can type in y equals 2x squared minus 4x plus 3. And we can see the exact location of the vertex. And if we click on it, it'll tell us exactly where it is. So it's at x equals 1, y equals 1. We could also do it in vertex form. So y equals x minus 3 squared plus 5. And we can see here that our vertex, if we click on it, is at 3, 5. So this is how you can use Desmos to check your work when trying to find the location of the vertex of a quadratic. Let's talk now about how to access your assignments on IXL using SBLink. So what you'll do is you'll click on the link that takes you to your SBLink, which should look like this. And you're going to log in the same way you would log into your computer. So the first part for your username is going to be the first part of your email address without the at sbcusd.ca.us. So it should be your last name, first initial, middle initial, and then the last 4 of your student ID. Then for your password, it's the same password you use to log into your Chromebook. From there, you'll go ahead and click Sign In. And it should take you to a page that looks kind of like this. You're going to go find the link that says IXL, which is right here. And I'm going to go ahead and click on that link. And it should take me to the IXL login page. So it should look like this. At the top right corner, it should say welcome and then your name. If it does not say your name, then you're not logged in and you won't receive credit for your work. As long as this is good, you can go ahead and close that tab out. And then you can go to your Google Classroom. And then you'll go and find the activity, which is here. And I'm going to click on the IXL link right here. And this will take me to the assignment that I need to complete. So that's how you log into your assignments on IXL using SBLink. Let's take a look now at the Graphing Quadratics Part 2 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here that'll take you to SBLink. This will allow you to access your IXL activity. So go ahead and log in, and then once you've logged in, return to this page and click on the link to go to your IXL activity. And it should take you to a page that looks like this. So the first question says, graph the function f of x is equal to 4x squared minus 8x plus 9. Well, we would use completing the square to figure this out, and once we do that, we should realize that we end up with x minus 1 squared plus 5. So from that, we can take that and make it 1 as our x-coordinate and 5 as our y-coordinate. That would be our vertex. Then we just plug in another value and solve. So let's plug in 0 for x because that's close to 1. So when x is 0, we get 4x squared, so that's just 0, and minus 8x, which is 0. So when x is 0, y is 9. So we just go ahead and plot that point there. Click submit. It tells us we got it right and gives us another one. Now the next one says x squared plus 8x plus 7. So we would use completing the square with this one as well. And when we do that, we should end up with x plus 4 squared minus 9. So we're going to go ahead and plot that. So our x-coordinate would be then negative 4, and our y-coordinate would be negative 9. So we go ahead and plot that right here. Then we'll pick an x value that's close to it. Let's try 0. So when x is 0, so x is 0, 0, we get 7. So we're left with just 7. So when x is 0, y is 7. So we'll go ahead and plot that right here. We hit submit. It tells us we got it right, sends us on to the next one. So you'll continue to answer these questions all the way until you get to the end. Once you get a smart score of at least 80, go ahead and return to your Google form and click next. This will take you to your before you go. Go ahead and fill out your before you go and then submit your work on Google Classroom.